Okay.
So hi everyone, welcome to this mock paper discussion by RJR Academy. So எல்லாருமே JEE exam போயிட்டு இருப்பீங்க. So already it's 3 days, 6 sessions is over. So sorry for the delay, it's a technical problem. So we wait for 2 minutes and let everyone join. So the session attend பண்றவங்க like few days later they are going to write the JEE paper. So we know JEE two sessions conduct பண்றாங்க and two times இருக்கு January and April. So this session is comparatively easy. இந்த மாதிரி தான் போயிட்டு இருக்குது. So இன்னைக்கு வந்து we'll discuss questions of mock paper questions from chapter chemistry and me who's handling chemistry in RJR Academy. So இன்னைக்கு வந்து short period of time maximum questions solve பண்ணலாம் and we are not going to deal with any theory, how to solve questions in an easier way. மட்டும் நம்ம பார்க்க போறோம். So I'll wait for a minute and let everyone join. So questions will be displayed here in this board. If you want, you can just take down in a short format. And options தான் வேணா and we'll discuss the questions. You can also put your answers in the comment section so that it could be an interactive session. So we start off with the first question. The weightage is more on organic comparatively inorganic, physical and organic. It is more of organic. So the first question, this 36 question, we know the pattern. There is 20 questions of MCQs and 5 of numericals. So we start off with the multiple choice question. So first, CH3, CH and C is reacting with hydrogen in presence of nickel and heat, and it is also treated with H3O plus. So there are we are getting two products, that is A and B. Products A and B can be distinguished by. So what is the difference between the JEE paper and NEET is the NEET always have the ஒரே ஒரு ஸ்டெப்ல மட்டும் தான் we get the answer. But JEE is not like that. We have more than a step. So இங்க வந்து first என்ன பண்ணுவோம்? We have to find what is B. We have to find what is A. Again, then the products A and B can be distinguished by. So this is the question. So I'll give a minute. You can solve and put the answer in the comment section. Okay. So what is on reacting? This compound on reacting with water and heat will get CH3, CH2, NH2, which is in primary amine. And on reacting with hydrogen presence of nickel, we'll get CH3, CH, CH, NH, and this is becomes CH3. Again we get CH3. This is in secondary amine. So we get secondary amine here, we get primary amine here. So how A and B can be distinguished? In simpler way, how primary amine can be distinguished from secondary amine is the question. So what are the options we have? The treatment of A and B is treated with CH3Cl3 in presence of basic medium, which is a which reaction? It is a carbyl-amine reaction. Okay. The action of HNO. And write this. This is carbon test. This is carbon test. And action of FnO2 is Lieberman's nitrosopus. Lieberman's nitrosopus. This is Hoffman's mustard oil reaction. So these are the three reactions given in the option. So we want to find what happens to primary, what happens to secondary, whether it can be distinguished by Starling test, Lieberman's nitrosopus, and Hoffman's test. First, what is carbon in this? I'm not going to detail this. Okay, what is carbon test? Carbon test is going to react with carbon test is going to react with CH3 in presence of a basic medium. So what happens to carbon test? Primary amines reacting with this carbon test, that is CH3 in presence of OH minus, they will give pungent smell. But when secondary amine reacts, there is no smell. So this way we can distinguish from primary amine and secondary amine. So carbon test is an example for this. So next what is there? Next it is Lieberman's nitrosopus. Lieberman's nitrosopus. So in Lieberman's nitrosopus, primary amine will release nitrogen gas, whereas secondary amine will have a nitroso compound. So by this way we can distinguish primary amine from a secondary amine. So first reaction is carbon test, second is Lieberman nitrosopus. The third is Hoffman's mustard oil reaction. This is Hoffman's mustard oil reaction. Hoffman's mustard oil reaction. So here the primary amine will give a smell of mustard oil, and secondary amine will have no reaction. So coming back, so the answer will be carbon test will give the it can be distinguished A and B. Reaction of HNO2 can be used, and third is Hoffman's test. We can also distinguish. So the answer is all of these. The answer for the first question is all of this. If you have any doubts, you can ask in the chat section. So next question. So we will move on to the next question. So So 28th question. Third question number 17. 28. Question number 28. Which of the following compounds does not exhibit geometrical isomerism? Which of the following compounds does not exhibit geometrical isomerism? Which of the following compounds does not exhibit geometrical isomerism? 28 question. Okay. So geometrical isomerism, that will be a plane of symmetry to show there is a geometrical isomerism. So in this first case, there is a plane of symmetry. In second case, there is a plane of symmetry. See, CH, double bond CH. Okay, C, H, again CH, you got one compound. So that is a plane of symmetry. So this is also having a plane of symmetry. What about this? Is there any plane of symmetry? What about this? Here, we'll check. What about this? This is also, we have a plane of symmetry. CH3, CH3, HH. But for this, there is no plane of symmetry. And for 20, check. 20 is 3. Third is the correct answer because here there is no plane of symmetry. Here there is a plane of symmetry. Here is a plane of symmetry. Here. So we have the plane of symmetry. Moving on to next question. Moving on to next 29th question. In the titration of sodium carbonate with hydrochloric acid taken in burette, the indicator of the indicator used is R. See, this is the factual question. Sodium carbonate with hydrochloric acid taken in the burette. The indicator is used with phenolphthalein for the first equivalent point, and next we get methyl orange for the next equivalent point. That's the factual question. We move on to next. Match the list 1 and 2. Match the list. Match the list 1 and 2. Okay. Here we got fluorine. Here we got fluorine, chlorine, oxygen, and sulfur. So what is the electron gain enthalpy is given in the list 2. The electron gain enthalpy is given in the list 2. So we have to just match the point. What is the electron gain enthalpy? It gains one electron and releases some energy is called electron gain enthalpy. Okay, electron gain enthalpy na or electron வாங்கும்போது how much energy is released is electron gain enthalpy. So look, fluorine, this is fluorine. We got chlorine, we got oxygen, we got sulfur. Okay. So which one has the more negative electron gain enthalpy? It should be for fluorine. Because why not fluorine? Fluorine is also needed 1 electron, but fluorine is very small size. But fluorine somewhat larger size. So fluorine is larger size. பெரிய size இருக்குனால electrons எல்லாமே it will be like somewhat more distance. Okay. Same shell ல இருக்கும்போது somewhat difference. But fluorine ல பக்கத்துல இருக்கும். So ஒரு electron வர்றதுக்கு we have to give some energy. But for fluorine it is very easy to reach the outermost shell. So fluorine is having more negative. So fluorine is having more negative 349. So this option is the option A is the right answer for the first question. We'll discuss for again fluorine also. Fluorine will get the next higher negative value. See, These row is having high negative electron being enthalpy. Why? Because it needs just only one electron to completely fill the outermost orbit. So either this is fluorine or chlorine. By the way, between fluorine and chlorine is having the more electron being enthalpy than chlorine. So the next is 328. So A should be this two. Again with oxygen and sulfur, oxygen we have the least value, that is minus 141, and sulfur we have minus 200. Okay, oxygen we have minus, that is least, because here the same concept, this concept can be used here also. Hope this is clear. Okay. So moving on to next question, 31st question. Which one of the following Which one of the following is the best method for preparation of acetophenol? First we want to know what is acetophenol. That is, which one of the following is the best method for preparation of acetophenol? Acetophenol. Okay. Before that, these are the reactions of Grignard reagent. What is Grignard reagent? Grignard reagent is an organometallic compound, which is type of sigma bonded organometallic compound. So we have organometallic compound. We have three types. There is sigma bonded, pi bonded, and we have sigma and pi bonded. The example of sigma bonded is Grignard reagent. The example of pi bond is we got ferrocene. What is ferrocene? This is ferrocene. This is ferrocene. These are iron coordination compounds. This is ferrocene, and sigma and pi bonded we have metal carbon. We have metal carbon. Okay. So this Grignard reagent is some extra points. Okay. So acetophenol. So we have to know about the structure of acetophenol. Okay. Acetophenol. Question number 31. This is acetophenol. So we'll check one by one, okay? We'll start off with the first that is so first option is THCOOEP plus CH3MgBr. Okay, so C2H3 reacting CH3 MgBr. So first we have to know about how Grignard reagent is. The mechanism for reaction of the Grignard reagent. So here there is a partial positive charge, here is a partial negative charge. Here is also a partial positive charge, here is a partial negative charge. This negative charge go and attach to this carbon having positive charge, and this positive charge go and attach this oxygen which is having negative charge. So finally we will get C. This carbon is getting attached, so we get CH3, and this magnesium is going to attach here. OMgBr. Again, here it is O and C2. Okay, wow. Hope it's clear. So now on hydrolysis, simple. We have to put OH here and H here. So what is the final answer? COH, it is CH3 and OC2 plus NGOH. This will be the answer for the first option. So, are we getting acetophenol? No. So, first option is wrong. So, we move on to the next option. Next option is PHCO CF plus CH3 MgBr. Okay, wow. So if the reagent undergo acetophenol கிடைக்குமா? I'll make this homework so you solve. Okay, just running out of time. We'll do more problems in a little time. Coming time when Marima questions for that. So we'll solve the last option. Last option to பார்க்கலாம். That is phenyl cyanide reacting with CH3 and GBr. Okay, so this is the compound. Plus CH3 and GBr. So here it is positive cell, negative cell, and here it is positive and negative. Okay. So this carbon goes and attacks this carbon, this positive cell goes and attacks this nitrogen. And what is the react? What is the product we get in our product? We get carbon, nitrogen attached to NGBr. This carbon gets attached to it. Again on hydrolysis. This in the OH happen, okay, OH happen, adding OH and H, you'll get C, double bond O, get CH3 plus ammonia gas is liberated along with MgOH. Okay. This is called acetophenol. Any doubts you can ask. This is the mechanism of Grignard reagent. Grignard reagent is the mechanism positive or negative or adding H plus and OH minus to the negative. Okay, then if you want to just copy off. Yeah. Next question. So answer for this question is fourth option. This one gives. Answer for this question is fourth option. Okay. Next is the third question. Hope it is clear. Now we move on to the third question. What is the third question? The decreasing order of acidic nature of the following compounds is. The decreasing order of acidic nature of following compounds is very easy. In direct question. See, what does NO2 group? What does NO2 group do? What does the NO2 group do? What does NH2 group do? And this is nothing with that. Okay. Nitro is a powerful electron withdrawing group. Okay. Electron withdrawing group. How? 2 minus electric. This electron withdrawal. So electron withdraw from the H plus only easier. It is getting released. more acidic nature should be for 2. Second option we are getting 2 2. Okay. Compared to amine or the first compound, என்ன இருக்கும் amine வந்து electron donating group. இந்த donate பண்ணும்போது H2S வந்து it's not going to release. Faster release ஆகாது. அப்போ இந்த group last இருக்கணும். அப்போ அந்த மாதிரி ஆகிற ஆப்ஷன் third option. So 33rd question the answer is 3. 33rd question the answer is 3. The question the answer is 3. Okay. It's moving on to 34th question. Statement 1 2 question. Moving on to 34th question. Cobalt 4 is known, but nickel 4 is not. And nickel 4 has D4 electronic configuration. Cobalt 4 is known, but nickel 4 is not known. We'll check, okay. Nickel is atomic number 20, so we get 3D8 configuration 4s2. Okay. Nickel 4 positive is 3D6 configuration is present. Cobalt is 27 and that is 3D7 and 4s2. Again CO4 is 3D5 highly stable configuration. So that is also possible. So CO4 is known, but Na is not consistent. This is a wrong statement. Na4 has D4 electronic configuration. Na positive 4 is having D6 configuration. This is not D4, this is D6 configuration. So both the statements 1 and 2 are incorrect. Both the statements 1 and 2 are incorrect. Any doubts you can ask? We will solve questions faster. So the good is that statement 1 is a false, statement 2 is also false. Moving on to the next question. A gas is allowed to expand at constant temperature from a volume of 1 liter to 10 liters against an external pressure of 0.5 atmosphere. If the gas absorbs 250 joules, the gas absorbs 250 joules of heat from the surroundings, the value of Q, W and delta E respectively. Q, W and delta E respectively. The gas is allowed to expand at a constant temperature from volume 1 liter to 10 liters against the external pressure of 0.5 atmosphere. The gas absorbs 250 joules of heat from the surroundings, the value of Q, W and delta E respectively. Okay. So we'll first find W. With W we can find delta E. Okay, what is the formula for W? W. So W is given by minus 3 into delta V. So what is the pressure? It is given 0.5 multiplied by delta V, change in volume. What is change in volume? 10 minus 10 minus 1 is 9. So 9.5 is minus 4.5 minus 4.5 atmosphere, right? Liquid atmosphere. So, and this is liter atmosphere. Liter atmosphere. Now to convert this liter atmosphere into joules, what we have to do? So minus 4.5 multiplied by 101. Minus 4.5 multiplied by 101 to convert into joules. That is minus 455 joules will be the answer for the work. So either this or this, okay? Either this or this. So with work, we can find delta E. What is the formula? Delta E is equal to Q plus W. Okay? Q is the amount of heat that is absorbed. Okay? Absorb means the value is positive. So Q is 250 joules and Q should be positive value. So this should be the answer. Without finding this, we can find this answer. But depending on so minus 4.55 joules is what? Is that is absorbed by this, so it should be a positive value. So in the option that is not positive value. But we can check this also. You know delta E is Q plus W. Q is 250 minus 455. That comes out as 205. So answer for this question. The question is what? Is there any doubts? Answer the calculation. So the answer for the 35th question is 1. Okay. Next question. Next we move on to 38th question. 38th question. We move on to 38th question. We take a minute break and solve the 38th question. So the 38th question. The compound that does not undergo half-form reaction. The compound that does not undergo half-form reaction. The compound that does not undergo half-form reaction. Compound that the compound that does not undergo half-form reaction. If you have any doubts, you can put in the chat section. I can read your chats here. Okay. So the compound that does not undergo half-form reaction. First, we have to know what is half-form reaction. Which compounds will answer half-form reaction? The compounds contain CH3C double bond O and CH3C OH. These two only answers half-form reaction. these two compounds, and the answer halofone reaction. So what is acetaldehyde? What is acetaldehyde? That is CH3 CHO. Correct? Yes. CH3 CHO. Which does not undergo halofone reaction. Okay. This is acetaldehyde. Next one is ethanol. That is CH3 CH2. First option, second option. So here it is having CHO group. So CHO group is that. CH2OH group is also there. CH2OH. Next acetone. Acetone is CH3C double group CH3. So again we have this group. So this is going to answer halofone reaction. This is going to answer halofone reaction. This is going to answer halofone reaction. So only one compound remaining is propiophenone, which does not undergo halofone reaction. Propiophenone that does not undergo halofone reaction. What is propiophenone? This is the structure called propiophenone. This is propio 1, 2, 3. And this is propiophenone. Okay. It's about the equation. The answer is propio. That does not undergo halofone reaction.